Okay, hello guys. This is going to be our first video. Today we are going to start working with the ultrasonic sensor. As you can see here, we've been working with this sensor in the last semester, but we didn't work too much, only in the last project. So today we are going to start working with it again. This is the HCSR04, okay? HCSR04. This is the most common ultrasonic sensor that you can find in the market. So it's really easy to work with it and to buy it. It costs less than 3 euros, okay? So we have one in the previous robot, in the all robots we were using in the first semester. So we are going to use that sensor we have in that robot. Okay, I'm going to show you how to manage and how to work with this sensor today, because we are going to do our next project with this sensor. Okay, we have here the principle of operation. As you can see here, this sensor is like a bat, okay, like a bat, like Batman. We have a transmitter, okay, this transmitter transmits a wave, okay, transmit a signal, and then we have an echo, okay, and this echo is received by a receiver. So we have both a transmitter and a receiver in our sensor. This sensor is going to feel, is going to know, is going to measure the distance between two objects, between our sensor and a solid object we want to measure the distance to. So we are going to make an order to the sensor to transmit a signal, and we are going to receive an echo that is going to tell us what is the distance between both of them, okay, between the solid object and the sensor. Okay, so we are going to use waves here, waves, these waves or signals, okay. We are going to transmit part of this signal into the receiver. Why part? Why does it say here part? Because some of the waves are going to be absorbed by the object, and maybe some of them are going to be transmitted to other parts of the object, okay? Not all the waves are going to come back to our receiver, okay? So we transmit these waves, okay? When we detect an obstacles, the waves travel back, comes back to our receiver, okay? This receiver captures these returning waves, okay? And the time taken for the travel is obtained as this formula we have here to calculate the distance between the two objects. As you can figure it out, as you can discover, this 340 is something related with the physics of the ultrasound wave. So the ultrasounds are going to go to a speed of 340. So we have to use that constant here in the formula to calculate how far these waves travel. So the distance is going to be this formula here, depending on the time that the waves takes to come back, okay, or take to come back, and the speed of those waves traveling around around the space of the Earth. Okay, why should we divide the total amount by 2? Because we have to travel one way and the way back. So we have to divide, because if I don't divide by 2, I'm going to obtain double of the distance. So I only want to know the time of the waves traveling through the object, not the time that takes those waves to come back. So I need to divide the amount of time between by 2. Okay. Okay. I think I'm going to be I'm being clear in this matter. Okay. So I think this is crystal clear right now. So now we are going to see how can we connect this artifact, this sensor, into our robot. Okay. So by now we have 4 pins. Okay, we have 4 pins, 4 inputs. Okay, so one of them is called VCC. This is the supply. This is the power supply. We have to connect this power supply into 5 volts. Okay, we have to connect this power supply into 5 volts. These 5 volts are going to be supplied by our robot, our Arduino robot. Okay. So, in the contrary side, we have the GND, the ground. This is the ground. This is 0 volts. Okay, 0 volts is the ground. We have to connect it to the negative. Okay, with 0 volts, with the ground of Arduino. Also, this ground is going to be provided by our robot. And now we have the 2 most important pins or inputs. One is an input, another one is an output. Okay. This is going to be an output and this is going to be an input. So we have the trigger pin. A trigger is when I shoot with a gun, with a pistol, I have to pull the trigger. So I have to shoot. So this pin is going to let us shoot the ultrasound sensor. So with this pin, we are going to transmit the pulse. We are going to transmit the ultrasounds. This is a positive pulse of 10 microseconds that will activate the sensor. Okay, so we are going to send that wave that I showed you before in here. Okay, with the trigger, I'm going to transmit this wave here. Okay, I'm going to let my sensor to transmit the wave here. Okay, and now the wave that travels back, okay, these waves that travel back here into the receiver, this is going to be captured. Okay, this is going to be captured by the echo pin. This will be at a high level during wave propagation. So this is going to receive that ultrasound. Okay, it's going to receive our ultrasound wave, and it's going to let the Arduino to process that sound. Okay, we are going to know, or we are going to see now, how this process takes part. Okay, we have here this diagram showing how this sensor works. Okay, so we have, when we pull the trigger, okay, when we tell the sensor to trick the signal, we are going to emit here, we are going to emit a pulse of 10 microseconds. Okay, we have now, this is the first step. Okay, a high pulse is applied to the trigger. Okay, We have some internal signals, okay, 40 kilohertz ultrasonic pulses, okay, this signal are transmitted, and then we are going to receive, okay, we are going to receive a pulse in our echo pin, okay. So this pulse received by our echo pin is going to determine how long did it take for our wave to travel between our sensor and the object. So it's going to let us calculate the distance between the surface we want to measure and our sensor, as I showed you before. Okay, I showed you before that process. Okay, so this was going to be the way to connect it, but I'm going to show you that way in our robot. Okay, so for now, that is the physics, that is the theory that is under the hood of our sensor. So we are going to show more related with our robot. Okay. How are we going to connect our sensor to the control board? The control board is the board that is in the top of our robot. This one, as you can see here, we have here the screen, the speaker, and now we have some connection and some pins in our control board. Board is the top one, okay? Control one. So our board, our control board, works as a breadboard. Do you know what is a breadboard? The breadboard is those boards that we use in the previous season when we were working with wires and we were connecting those wires. We were using breadboards. So those breadboards are boards that help us connect different devices, okay, together. So we are going to use these pins like a breadboard. Okay, you can see here these red lines are showing us that these pins, these inputs are connected. So if I put some wire here, this wire is be connected with all these inputs, with all these holes, okay? So we can connect everything here. For example, if we want to connect 5 volts in all this line, I can connect 5 volts in one of these dots, and I'm going to get in every dot, in every hole, I'm going to get 5 volts. So for example, I can have here 5 volts, and I can have here the ground, okay, connecting the ground here. I'm going to show you how to connect the ground also. And as you can see here, these two holes in the extreme of this part of the board are also connected. These two, these two, these two. These are independent also, and this one also are independent. Okay, and then we have all these holes that are completely independent. Okay, so this works as a breadboard. We can use only this line here, this line, and these two ones, because if we want to connect some wires with other wires, if I use these ones, I can use it. I only can use these holes here if I'm going to mold them, okay? Si los voy a soldar, okay? So in other case, we are not going to use these ones, okay? As the same I can do with this other breadboard here, with this other breadboard here, and with this other breadboard here. Okay, I can do as equal in this one. Okay. So I have also in my console board I have two kind of connections. One is called TK2, TK and the number. These are these white little things that our robot has on top of the console board with three connectors. We are not going to use these ones up to now, but we are going instead using these ones, the TKD, that are these ones here, or here, or here, okay? This one TKD. We are going to use these ones. So in this project, we are going to use this part here to connect our SR04, our ultrasound sensor. And I'm going to show you how to do it, okay? So in the next part of the video, I'm going to show you how to do that, okay? If you have some questions about the breadboards, you can ask me, okay? Because I don't know if you understand exactly what a breadboard is, but it's pretty simple, okay? It's a board where you can connect your wires. So you have the connections here for you to see, okay? So we can continue now. So how are we going to connect our ultrasound sensors? In this project, we are only going to use one ultrasound sensor. So we only have to connect the one in the head, okay? We are going to measure something that is going to be forward, okay? Something that is going to be opposite of our robot, because we want the robot to go straight, okay? So we want the sensor to be in this part, in the forward part of the robot, okay? So our sensor, as I told you before, has four inputs. Well, some are input, some are output. So we have to connect, as you can see here, this is the black wire is the supply power, the power supply. So we have to connect this power supply into 5 volts. And these 5 volts are going to be provided by this output here of the Arduino robot. We saw before the TKD, in this case the 3, 4, and 5, 3, 4, and 5 are these holes here. Okay, so the first hole is 5 volts. So I have to connect this hole into my power supply, into my VCC of my sensor. Okay, then secondly, I have to connect the GND, the ground, that is the blue line. I have to connect it into this hole here, okay? And the one in the middle, that is the red one, this is going to be the trigger, okay? This is going to be the trigger. So this is a digital output. It provides a digital output into our sensor, okay? And then the last part is that I need a digital input to manage, to deal, to process our input from the echo, okay? and this is going to be this is this yellow line here that is going to be connected into this hole here in the TKD4, okay, in the middle, and this is going to be our digital input, okay. You have here the, the setup of our sensor. Very good. As I told you before, I'm going to show you how to mount, how to fix your ultrasound sensor, okay? So this is your ultrasound sensor, okay? And I'm going to set this ultrasound sensor here, for example. This is the forward part, okay? So we are going to try to fix our sensor here because I want to measure the distance that I have forward, okay? So we are going to try to do that because, you know, I don't have here any available parts, any available place to do it. So for example, I can do it here or maybe here, okay? As I told you in the previous part of the video, we are going to connect the sensor here, okay, in these holes here. So first we are going to set the sensor, okay, and now I'm going to take the cables, the wires, sorry, I'm going to take the wires, oh my god, sorry, I had an accident. Okay. And now that everything is all right, I have an accident. I'm going to set. Sorry, I'm going to here to set the wires. Okay. As you know, it's a little difficult to work with this robot because we have not a lot of space. So I'm going first, well, I'm going to show you. I'm going to wire the sensor. For example, this wire is going to be here, and these three wires are going to be here. Well, so we have the 4 wires set, and now I'm going to introduce the wires into this hole here because I want my sensor to be in this position. My sensor is going to be set here. I can stick some tape in the sensor to fix it, okay? And now I'm going to just connect or wire these four outputs I have in my sensor. So the first one I told you in the video, for example, the red one, that is the VCC, is the power supply. The power supply is going to go to this hole here, TDK3. So I'm going to wire in the down parts. Try to be careful and the wire to be connected, well connected, because otherwise you are not going to have a connection. So I have this wire connected there, as you can see. I didn't connect it properly, sorry. It's going to be here. Okay, it's going to be here. You can see, okay, you can see the wire here. This is power supply, okay. So now we are going to connect. Oh, okay. I made a mistake. The power supply is the last one. Okay, sorry. So it's going to go in the last hole. Oh my God. Here. Okay. Here. This is the last hole. Is the power supply. Okay, the ground is the first. The ground is the first. Okay, try is maybe it's going to be good for you to stick some tape, the black tape you have in your Arduino, or maybe you do like here, you only bend a little bit the wire. Okay, you can bend a little bit the wire. So now the ground is this wire here. It's this wire, this light brown. So this is going to go in the first. This is going to go in the first hole. In the first hole. Here, okay. And I now can bend a little bit the wire, okay, to stick on it. And now I have to connect the echo and the trigger. First, the trigger is the second. The trigger is now here, the orange, okay, so the orange is going to be in the middle. The orange is going to be in the middle. It's better for you. It's better for you to stick out. Oh my God. It's better for you to stick a little tape on it. And now I'm going to put here in the middle. I'm going to put here in the middle the orange. That is the trigger. Oh my God. Maybe it's better to put the second, to put this wire in the second place. Okay, now I did it. So I can bend a little bit the wire. Be careful, because the wire couldn't or can't touch themselves, because you are going to have a bad connections. Your project is not going to work. And the last, the echo is going to be here, right here in the middle. So I'm going to introduce this into the middle here, okay, and I bend it a little bit. So now I have my 4, as you can see. I don't know if you can see properly here. Here I have my 3, the power supply, trigger, ground, and now here I have the echo, okay? And I have here my ultrasonic sensor set. So I have to be careful with the wires, and I can set them in a way, for example now, that maintain my sensor stable, or maybe I can stick some table, I can put some table on it to stick on this position, because I need to measure from this part forward. Okay, so this is the way you have to do it. Okay, now I'm going to show you what we are going to do today. First, I'm going to present you a program for this Arduino robot with this sensor working. Okay, you can forget about these two sensors, because now we are going to work only with this one. Okay, the one forward. Okay, and we are going to manage this setup with this program. I'm going to send you to the Moodle. Okay, I'm going to upload into Moodle for you. As always, we have to include some libraries, the Arduino robot, as always, the wire that controls the way the data is sent to Arduino. We also have to include the SPI library. So now we are going to declare a trigger pin and an echo pin and a variable. Well, these variables I don't really need it, but it's okay. It's only a variable that is going to appear here in the text that is going to show this robot to you on the screen. So you can forget about that. So in the setup, we are going to robot begin as always. We have to do this to set up our robot. Then we are going to begin the TFT. The TFT is the screen. Okay, so we are going to start the screen. And then we are going to declare, we are going to say that the trigger pin is an output. Okay, so as this is done, we are going to the loop, and in the loop we are going to say that we choose the color black to write on the TFT on the screen, and I'm going to write on the TFT on the screen that the distance sensor, this function here, is going to tell us what is the distance between our sensor and the object. Okay, and these codes are to write in one place on the screen. So, and now we are going to wait for 2 seconds. Okay, it's pretty simple. So what the distance sensor function performs is the following. We have two variables, the trigger pin and the echo pin, that were declared here. Okay, we declared those variables here, global variables. So we have these variables that are going to be, as I told you previously in the video, the TKD3 and the TKD4. We are going to write into an output, a digital output, that is going to be the trigger pin, a low signal. Okay, we are going to delay a microseconds. This function is new. With this, I'm assured that I'm going to wait for 2 microseconds. That is almost nothing, but I'm going to have my work done, because my signal needs these 2 microseconds to start working. Okay, I can do anything else in that period. So I need that. So now I pull the trigger. Okay, I trigger. So I write a high signal in the trigger pin. I send a 1 into my trigger pin. Okay, I delay for 10 microseconds, and then I write a low pulse. Okay, and then I read my, well, I'm telling the Arduino that my echo pin is an input. Okay, and that's, as I told you in the video, and I'm going with this echo pin, I'm going to get, with this pulsing, I'm going to get when this echo pin is going to get a high pulse. Okay, I'm waiting for a high pulse, and this is going to give me the duration, the time that pulse lasts between the two objects, my sensor and the object. So with this another variable centimeters, we are going to get the distance in centimeters. We can also have the distance in another kind of measure. For example, okay, whatever, another like meters or whatever. Okay, but I have to do another formula for that. So then I'm going to return the centimeters. Okay. Now you know what you can do with this robot and this function, and I'm going to show you this thing, what you have to do in this project, in the project that we have currently in hands. Okay? What I want you to do is the robot has to continue, okay? Has to go forward. For example, my robot has to go forward, so it has to go forward, has to go forward until it reaches 10 centimeters from an obstacle. So I have to avoid the obstacles and continue. And continue my previous path. Okay, or not the path, but the direction. Okay. So that is pretty simple. Okay, I have to avoid these obstacles and continue. But what happened if I found some obstacles in the right? Okay, for example, I found some obstacles here. Okay, I'm going to tell you what you have to do. You have to go here, turn right, and then I found a new obstacles. Then I have to turn around and go backwards, okay, until I follow this direction here, okay? But what happened if I again found another obstacle here? What happened now? Okay, I'm going to show you what you have to do. You have to go here, 20 centimeters, I turn right, I found a new obstacles, I turn around, I found a new obstacles, so I have to turn around and go backwards, okay? I have to go away from this closed alley, from this cul-de-sac, from this part I can go through. So if that happen, I have to take into an account that I have a path that I can follow, and I have to go backwards from the same place I was coming. So you know what I have to do, right? Go, no, go, no, go, no, come back, and come backwards. Now I have to go backwards. Okay, I have to go backwards. Sorry. My robot has to go from the same path it was coming, but backwards. Okay. So now you have your work. Have a good job.